Welcome to Introduction to Swift Programming Language course by Simplilearn. In this course, you will get a solid foundation in Swift, the powerful and intuitive language used to build apps for iOS, Mac OS, Watch OS, and more. You will start with the basics like variables, data type, and control flow, gradually move on to functions, object-oriented programming, and working with Swift unique features like optionals and closures. By the end of this course, you will be confident writing clean, efficient Swift code and ready to start building your own Apple ecosystem apps or move into more advanced iOS development. Let's start by understanding what Swift actually is. First and foremost, Swift is a programming language created by Apple. Think of it as a tool that developers use to give instructions to computers, especially Apple devices. It's designed to be both powerful, meaningful, it can handle complex tasks, and intuitive, making it easier for programmers to write the code. Swift was built with safety, performance, and good design in mind. This means Apple focused on a few key things. Safety. Swift helps prevent common programming errors like accidentally accessing the wrong part of the computer's memory. This leads to more reliable and stable apps. Performance. Swift is designed to be fast, so apps built with it run smoothly and efficiently. Design patterns. Swift encourages developers to write their code in structured and organized way, which makes it easier to understand, maintain, and expand. Swift primarily used to create apps for Apple ecosystem. That includes everything from apps you see on your iPhone, which is iOS, and iPad, which is iPad OS, to the software that powers your Mac, which is Mac OS, Apple Watch, which is Watch OS, and Apple TV, TV OS. But its use is actually strictly limited to Apple products. One of the great things about Swift is its modern syntax. The way you write code in Swift is designed to be clear, conscious, and even enjoyable. It's generally considered easier to learn and use than some older programming languages. Finally, Swift is an open source language. This is important because it means that Apple has made the important language available for anyone to use, modify, and distribute. This has led to a large and active community of developers who contribute to Swift development and provide support to each other. Let's move on to the process how downloading and installation takes place. So as you can see, I have opened swift.org to install. So this is the official platform where you can run the code for installation purpose. So you can download it for Mac OS, Linux systems as well as Windows. So the latest release of Swift is 6.1. So you just need to download. So as per your system requirements, you should download what version is compatible with your system and you have to run it. So here I'll be using Windows as my primary system in which I'll be able to run the Swift code. So after downloading, so according to this document, you can follow the instructions and download it in your system to run the Swift code. Now in Windows, you can run Swift three ways. One is via command prompt, one is with the icon that they have provided, and the third way is VS Code. I will be majorly using the system's old way, which is from the icon, which is basically converting any text document into .swift file. So you can write your code in any text document, convert it to .swift file and upload it to the Swift compiler, which will be already installed in your system. This is the procedure for VS Code. There is another two packages that you have to install in VS Code, and to run it in command prompter you need to copy the path as you do it for Python or any other process and copy and paste it in the environment. So let's run a small program first to check if your Swift is running or not. So here I'll be creating a new text document which will be renamed to .swift file. So let me give this as test.swift file. So it will give you an option and you just need to give OK. And here you can write your code. So I will be writing, first I'll be importing Swift, and let me just print a welcome statement. So it's print So the output for this should be the statement of hi, welcome to the course of learning Swift by Simplilearn. So you have to just save the file and you will see a compiler here. You need to just select the file. The file is on desktop. You can see test.swift and you need to open it. First, you need to compile. If the compilation is successful, you can run the program. And here is the statement printed. So this is the first program to check if your Swift is working or not. So you guys are aware of how the download and installation of Swift take place. And also, please do try it with your own printing statement. Check if Swift is running. Try it with different statement and check in command prompt and as well as VS Code if you are also using those both. Here the central question here is how do we declare a variable or a constant to further code? And Swift gives you two main ways to do, which we will look at in parallel. Explicit declaration. As the name suggests, with explicit declaration, we are very clear and specific about the type of data we want to store. For example, we use var, that is var, to declare a variable. If we write var x int is equal to 5, we are saying I want to create a variable named x. It will hold an integer value and its initial value is 5. Similarly, var float declares a variable named y that will hold a floating point number. Now let's look at implicit declaration. Swift is smart enough to often figure out the data type for us. This is called type interface. For example, if we write var second is equal to 5.6, Swift often knows that 5.6 is a floating number. So it automatically sets the type of the second to float. And if we write var first is equal to 8, Swift interface that 8 is an integer, so it sets the type of first to int. Let's move on to what kind of data types are there. So here initially for whole numbers we use int or uint. As we all know, int as per other programming language it's used for whole number, but here we use uint for unsigned integers. And also we have float, double, boolean, string, character, optional and tuples as well. So we know float is a point number with smaller decimal point. And double is a 64-bit floating number which is a larger point value. And boolean is either true or false as a value, and string is a collection of characters which is a name or a collection of alphabets. Character is a single character, a single alphabet. And optional represents a variable that can hold either a value or a no value. Tuples, this is used to group multiple values in single compound value. Next, let's talk about string interpolation. String interpolation allows you to embed variables or constant directly within a string literal. This means you can insert values into the middle of the string without having to break the string apart. The syntax of this is use backslash and parenthesis, which is a backslash and a name. Anything inside the parenthesis is evaluated and its result is inserted into the string. Let's move on to string concatenation. String concatenation is a process of combining strings together using the plus operator. The syntax here is straightforward. If you have two strings A and C and if you want to combine them and store the result in a new string A, you would write let A is equal to B plus C. Now let's see a small example regarding string interpolation and string concatenation. So here, firstly, I'll give you an example of interpolation. So first, let me give var variable name is equal to Alice. And then I'm going to print hello. And then I'm going to put the name. Let me add a explanation mark and this. So here eventually it won't print hello and name, the same statement, instead of which the name contains the name called Alice. So it will print hello Alice. So let's save this and run it. Okay, so first we have to select the file. Let's compile. It's successfully compiled, and if we run, we get, okay, it's printing name because I have missed the backslash. So let's give the backslash and name and save it, and then you can compile this file now. So let's check the output of this. So save it, and then you can run it here. You can run it even in a command prompt. So I have missed a space. So here, so let's correct our errors. Save it, and then again you can compile your file. It's completed, and you can run. So here we have hello Alice instead of the name. So moving on to concatenation, I'll give you an example here only. So let's say I'm giving variable a is equal to hi, and also I'll give variable b is equal to how are you doing. Simple. Now I need to add this. So for that, I'll be storing it in a variable called c, which will be a plus b. Let's print c and c. So ideally the output should be hi, how are you? So I'll give a space so that you'll understand. So let's save this and compile. Sorry, first you have to select the file, compile, successful, and then you have the output hi, how are you doing? So these are the concepts of concatenation. Let's move on to the next topic, which is type interference and type safety. So Swift has the ability to often automatically deduce or figure out the data type of a variable or a constant based on the value you initially assigned it. This means you don't always have to explicitly state the type. Now, what about type safety? Swift is a type-safe language. This means that the Swift strongly enforces the rules about how different data types can be used together. It prevents you from performing operations that don't make any sense, such as typing to adding a number to a piece of text. This type safety is a powerful feature because it helps catch more errors early in development process when they are easier and cheaper to fix. By preventing these errors at compile time, Swift makes your code more reliable and prevents unexpected behavior while your app is running. Now let's talk about comments and code readability. Comments are essentially notes that you add to your code to explain what it does. They are ignored by Swift compiler, meaning computer doesn't try to execute them. They are purely for human readers. Swift supports two types of comment: single line comment, which starts with 2 slashes, and multi-line comment, which are enclosed between symbols. I'll give you an example of both now. So as you can see, we have performed concatenation. So I'll be giving single line, which is 2 ashes. So this I'll type hi is assigned to A. So like that you can give single comment, or else if you want to do multiple line commenting, it is backslash asterisk, and then you can type this program is about concatenation and it prints hi, how are you? So these are the 2 second sentence, so you just can close it up by the same symbol inverse. So this line and also this line will be ignored by the computer. It is not considered a part of the code. So code readability is about writing code that is clear, concise, and easy for others to understand. It's a crucial skills for any programmer. There are several key principles that contribute to good code readability, which includes clear names, consistent style, small functions, and helpful comments. Now let's move on to some part of coding. So we have control flow conditional statement, which include if statement, else statement, and else if statement. So the if statement is most basic condition statement. It allows you to execute a block of code only if a specified condition is true. Now you can see I've given you an example of syntax where syntax is if, the condition, and open and close parenthesis. Coming on to else statement, the else statement is used to conjunction with an if statement. It provides an alternative block if the code to execute in the if condition or if statement is false. Here also the syntax is very similar. We have else and open and close parenthesis, and between there is the code. Coming to else if statement, when you need to check multiple conditions in sequence, you can use else if statements. They allow you to chain together several conditions and execute the corresponding code block when a condition is met. The syntax here is if else, the condition, and open and close parenthesis in between the code. Let me give you an example of this type of coding using if-else statement. So for if loop, let us execute a program where we can check the number is a negative or a positive or a zero also. So what was the syntax? We have if the condition. So the condition if firstly the number should be greater than or equal to 0. That means it is a positive number. So we'll give the print statement, which is print the number is positive. What will be the second condition? The second condition will be else if number is less than 0. We should print the number is negative. And then we have else statement. So here there is no need of any other condition, because if it is not lesser than or greater than 0, it is 0. So I'm just directly going to print the number is 0. And you can close it. Now let me initialize a number. So let the number be -5. So we'll giving now save this and let's execute it. Okay, there is a missing, so I'll save it and I'll run the program. First let me close the previous one. So let's select this file and compile. There are no errors, and then we can run it. The number is negative. Let's move on to the next topic, which is control flow loops. So for looping, there is for loop and while loop. The for loop is used to iterate over a sequence such as the element in an array or range of numbers. It executes a block of code once each item in the sequence. The syntax involves specifying the item variable, the collection you want it to iterate over, and the code if you want to execute for each items. For example, if you could use for loop to iterate over an array of names and print each name, or iterate over a range of numbers and calculate their squares. But whereas in while loop, the while loop repeatedly execute a block of code as long as specified conditions remains true. It continues to loop until the condition becomes false. The syntax involves writing while followed by condition you want to check, and the code block you want to repeat within curly braces. For example, if you could use while loop to repeatedly ask the user for input until they enter a valid value, or to stimulate a game where the game continues as long as the player has lives remaining. So let's see an example for both kinds of loop. So firstly, we'll check if the number is even or odd in for loop. So for number in 1 till 5. So this is the operator that I'll be discussing in the further classes, where instead of range as in Python, we use a range operator here. So this will give us the values from 1 to 5. So the condition being if the remainder after dividing the number by 2 is equal to 0, then we have to print it is even, else we can print it is odd. And then you can close the program. So as I told before, the syntax is for the range, and then we have the conditions for it to run. This will run from 1 to 5 because we have already given the range. So I'm going to save this and let's run it. So let's select the file, compile it. It's compiled and see it is odd, even. Okay, I'll specify the number as well in the program so that there is the number also mentioned. So let's give backslash the number, and same here also we can give the same. Save it and then you can execute this. It's successful, and you can see here 1 is odd, 2 is even until 5. It is looping until 5. Now same condition if I use a while loop. So I'll keep this. I'm going to use, instead of a for loop, I'll use a while loop. So here the condition will be the number should be greater than 0. This loop will start and I have to initialize the number. And after this, I'll also ask the number to keep decreasing so that until a negative number comes, I can execute it. So this is the decrement operator, and you can close the loop. And I have to initialize the number also. So let's say the number as 5. So 5 times it should execute. 5, 4, 3, 2, 1. I need to get the answers for these. Number is equal to 5. So here firstly we have given number is equal to 5. It will loop. While will loop until the number is 0, and after checking each number if it is even or odd, I'm decrementing it by 1. So let's see, save it and then select the file, test.swift, compile, there are no errors, and run. So here you can see it is looping in a decreasing order. So 5 is odd and all these things. Try using different codes, like you can take another question and you can start using if else loop or while loop or for loop according to the problem or your knowledge. Moving on to the next topic, it's control flow range operators. So firstly we have closed range operator. The closed range operator denoted by 3 dots defines a range that includes both the starting and the ending values. So I've already given you an example which is 1.5, which is representation of 1 to 5 numbers. And then we have half open range operators. The half open range operator denoted by ... either it is greater than or equal to, defines a range that includes the starting value but exclude the ending value. For example, the expression is 0 till less than 3, which represents 0, 1, 2. Next we have optionals and optional binding. In Swift, an optional is a type that can hold either a value or it can hold a nil. Nil essentially means no value. We use optional to handle situation where a value might be missing or undefined. This is a common scenario in programming. For example, a function that searches for a user might return an optional. It returns the user if found or nil if not found. You declare a variable or constant as an optional by adding the question mark. So moving on, we have optional binding. Because an optional might not contain a value, we need to be safe way to access its underlying value. This is where optional binding comes in. It allows us to safely unwrap the optional and access the value only if it exists. Swift provides two main ways to do this. One is if-let and one is guard-let. If-let construct executes a block of code only if optional contains a value inside that block. You can use the unwrapped value, whereas guard-let construct is used for early exit from the function, method, or loop. If the optional is nil, the guard statement else block is executed, typically to exit the scope. If optional has a value, you can use unwrapped value after the guard statement. The next topic is nil coalescing and optional changing. This covers two more techniques in Swift that help us work effectively with optionals, which is nil coalescing and optional chaining. They provide concise way to handle situation where the value might be missing. A nil coalescing operator provides a default value to use when the optional is nil. Whereas in optional chaining, it provides a way to access properties and methods of optional that might itself be nil or might contain a value that leads to another optional and so on. So moving on, we have arrays. Arrays are one of the fundamental data structures in Swift used to store collection of ordered items. Arrays in Swift are stored in ordered list of elements of the same type. You can declare an array using square brackets. Here are few examples. So you can go through the examples where we have given various number of declaration. We have var numbers is equal to int 1, 2, 3, or else you can give names also or an empty array also. You can access elements in an array using their index, which starts from 0 in the first element. For example, number 0 is referring to the first number of the array. Arrays in Swift are mutable, meaning they can be changed if they are declared using var. Here are some common ways to modify the arrays, which is append, insert, remove, or remove last. Next, we'll move on to collection of dictionaries. Dictionaries stored elements as key value pairs each key in unique with a dictionary and is associated with a specific value. And a couple of examples include var ages, where string and integer is given, where you can store string or integer values. We can also give an empty dictionary, which is also given on the screen. We have var empty dictionary and we're giving it as string, and it is empty, it has no values. In dictionary, elements are stored as these key value pairs. You use the key to look up its associated value. A crucial point to remember is that all keys in a dictionary must be of the same type and all values must be of the same type. For example, in the ages dictionary, all keys are strings and all values are integers. You access a value in a dictionary by providing its corresponding key within square brackets. And there is an example also given, which is ages, and it's declared as Alice's. Dictionary in Swift are mutable, that is changeable, if they are declared using var. But if you want an unmutable dictionary, you can use let. Even it applies for arrays also. You can add a new key value pairs by assigning a value to a new key, like ages. Charlie is equal to 28. Moving on, it is sets. Like arrays, sets stored a collection of values, but with a crucial distinction. Sets only store unique values. Any duplicate values you try to add are automatically removed. Here's how to declare a set. There's an example. We have var empty set and we have set it to string. And we can enter the value as 1, 2, 3, 4. Var unique number set into 1, 2, 2, 3. In this example, even though if the numbers are repeated, this will consider it as 1, 2. The key characters of sets are that they store unique values and they do not maintain any specific order. The order in which the elements are stored in a set are not guaranteed. Sets are particularly useful in scenarios where you need to ensure that you don't have any duplicated values and where the order of the element doesn't matter. Here are some of common use cases. You can use it for checking for membership, removing duplicated elements, performing set operators, union, intersection, and difference. Next, we have iterating over collection. The for in loop is very common and convenient way to iterate or go through all the items within a collection. The basic structure is for item in collection and the code. When you iterate over an array, the for in loops gives you each element of the array in the order they are sorted. When you iterate over a dictionary, the for in loop provides you with each key value pair. Each pair is represented as a tuple where the first element is the key and the second element is the value. In sets, you iterate over for in loop gives you each unique element in the set. However, remember that the sets do not have a defined order, so the element will be provided in an arbitrary sequence. So let's quickly see an example for this. Firstly, let's see an example for in loop over an array. So firstly, let's give an array. Colors is equal to sum of the colors, which is red. Let's give it green. And blue. And so in for color, in colors, we can have print. We can print the color. It iterates through each string in the color array and prints it. So let's execute this, saving it. And there is no errors and it should iterate. So we have all the 3 colors which is in the array of colors. So now let me execute for a while loop in foreign format. So it's a similar way, but let's give a dictionary first. Ages is equal to, we'll give Alice. Then the age will be 30 and you can give Bob as the second name and the age be 25. This is the dictionary, and then we have for loop. We have 2 of them, which is name and age in ages. And then we can print the name. Here it won't print name, but the value stored in the name will be printed as discussed before. Then we have age also in the same way. And you can give full stop, and I think that should work. We'll check for errors, we'll compile it. So there are no errors, so I'm running it. So we see that I've given only 2 names. So we have Alice is 30 years old and Bob is 25 years old. So this is an example for a dictionary using for in loop. Moving on to the next topic, it is function, parameters and return type. Parameters input for functions. Functions can receive data when they are called, and this data is passed in through parameters. Each parameter has a key parts, a name which is what you can call the parameter, and a type which specifies what kind of data the parameter can hold. The syntax is parameter name and parameter type in a braces. For example, if a function takes a person's name as input, you might define it as name string. Return types. Output from function. Functions can also produce a result after they have done their work. The result is called the return value. The return type specifies the type of data that functions will send back. You indicate the return type using an arrow followed by the type. We'll see the syntax for this in the coming up program. It's important to note that function can return values of any data type, whether it's simple type like an int or a more complex type like an array or custom object. So let's see a classic example of functions. Let's see a basic example of using a function. So firstly, let's declare a function. So function is, and let's give it add numbers. And I want a as integer. Here, if you are declaring any kind of variables which is the data types, it should be in capital. The first letter should be in capital. It's a case sensitive programming language, so you might miss out on that. And then we have an arrow, and then this should return me, this function if I call it should return me the value a plus b. It's a very simple function where you enter the values and the return type should be the addition of the two of the values. Now let's call this. The result will be calling the function by the name, which is add numbers, and I'm going to give a as 5 and b as 3. Now after calling the function, let's print it. So we have print, the sum is, I need the result, so backslash the result. So let's save it and run it. So here the answer should be 8. So let's see if we are able to achieve that. So as usual, open this, select the file, firstly compile. There is an error, I left out a space, so let's give that space, save it, and then select the file again, compile, and it's done without any errors, so we can run it. So the answer is, the sum is 8. So this is a very basic program for a function and a calling function. So the next topic is object-oriented Swift class and objects. So we'll have an idea of what classes and objects are. So in Swift, a class is like a blueprint or a template. It defines the structure and behavior of a certain type of entity. A class specifies the properties which are like data or attributes, and methods which are actions or functions that objects of that class will have. Think of a class as a general description. For an example of class car, define a property like color, model, or making year. The methods like start, engine, and drive. Objects, which is concrete entities, on the other hand, is a specific instance of a class. You create objects based on the class definition. Each object has its own set of values for properties defined by a class. So let's see a classic example of classes and objects here. So some of the properties and methods of object-oriented Swift are holding data. Properties are essential variables and constants that are associated with the class or its objects. They store data or attributes of an object. For example, if you have a class called dog, its properties might include a name, breed, age. Each dog object will have its own values for these properties. Whereas methods, which are like defining the behavior. Methods, on the other hand, are functions that are associated with the class. They define the actions or operation that objects of the class can perform. Using RDog as an example, it might have methods like bark, fetch, or eat. These methods define the behavior of the dog of the object. Then we have instance method. The method we have been talking about so far are instant methods. This means that they are called on a specific instance or an object of the class. For example, if we have a dog object named my dog, we would call it bark method using syntax my dog bark. Each dog object has its own copy of instances. So next we have object-oriented Swift initializers, where we have to ensure proper setup. Initializers are special methods within a class that are automatically called when new instances or object of that class is created. The main job is to make sure that the new object is properly set up and that all the properties have valid initial values. You define an initializer using a keyword called init. Self is a keyword used within the initializer to refer to the instance or an object that is being created. This helps to distinguish between the property name like name and the parameter also, which is also called as name. Then we have default initializers. If a class provides default values for all its stored properties and doesn't define any custom initializers, Swift provides a default initializer with no parameters. This means that if all the properties of your class already have a starting value, Swift will automatically create a simple initializer for you, so you don't have to write it yourself. Moving on, we have inheritance and overriding. Inheritance allows a class to inherit property and method from another class. This promotes code reuse. Instead of writing the same code multiple times, you can define common properties and methods in a superclass, then have subclasses inherit them. This also establishes and is a relationship. Overriding is a subclass that can provide its own implementation of a method or a property that it inherits from its superclass. This is called overriding. So we'll move on to the next slide, which is access control. Control the visibility of the code. Access control lets you restrict which part of the code you can access other parts. This is important for encapsulation, which is key principle of object-oriented programming that helps you hide the internal workings of a class and prevent unintended modification. So we have three types of it, which is public, private, and internal. In public, entities declared as public are most accessible. They can be accessed from anywhere within the same module and also from the code in other modules that import your module. In contrast, private is most restrictive access level. Entities declared as private are only accessible from within the defining type. This means they can only be used code inside the class or structure when they are defined. If you don't explicitly specify an access level, Swift uses internal by default. This means that entities declared as internal are accessible from any source file within the same module but not from the outside the module. So here's an explanation of object-oriented Swift self and superslide. The keyword self refers to current substances of a type. You use self to access the properties and methods of the specific instances. For example, if you have a class person with the property name inside the person's class, you would use self.name to refer to the name of a particular person object you're working with. Whereas in super, the keyword super is used in a subclass to access members, which is properties and methods of this superclass. This is particularly useful when you're overriding a method in a subclass but still want to call superclass implementation of that method. You can also use super to call the superclass initializer. For example, if you have a subclass student that inherits from a person, you could use super.init. In students initializer to call person's class initializer and set up the inheritance properties. Next, we have structures. A structure is essentially a blueprint or a template that allows you to define a new type that fits your specific needs. You use them to structure data in a way that makes sense for your program. The characteristics include holds relatable data, that is, structs allows you to bundle together variables or constants known as properties that are related to each other. This helps you keep your data organized. The second being can have behavior, which is methods. In addition to holding the data, structs can also contain functions called methods that define actions or operations that can be performed on that data. Thirdly, we have no inheritance. Unlike classes, structs do not support inheritance. This means you cannot create a new struct that is based on an existing struct. Some of the use cases includes A common example representing coordinates like a point with x and y values. You might also use them for things like representing size, colors, or other small self-contained data structures. Next, we have enumeration. An enumeration essentially lets you create a custom type that represents a fixed set of possibilities. Each of those possibilities is called a case. Some of the characters include fixed list of possible values. You define all the possible values that a variable of the enum type can hold. This provides type safety and makes your code more predictable. Secondly, we have improved readability. Using enum's descriptive case names makes your code clearer and more self-documenting compared to using raw values like string or integers. Lastly, we have optionally associated value for context. In Swift, enum cases can have associated values which allow you to attach additional information to each case. This can be very useful for providing more context. Some of the use cases include representing states like different states of a process, example loading, success, or error. We can also represent days of the week and also setting with a fixed number of possibilities. Next, we have protocols. Think of a protocol like a contract or an agreement. It declares a set of methods and properties that a type must implement if it wants to conform that the protocol. Some of the characteristics of protocol have these key characters, which is list requirements, that is what to do. A protocol specifies what functionality a conforming type must provide, but it doesn't provide the actual implementation. Enable polymorphism. Protocols allow you to treat different types in a uniform way as long as they conform to the same protocol. Usually no implementation in protocol itself. Typically, a protocol only declares the method signature and property requirements, not the actual code that makes them work. Some of the use cases include using to achieve flexibility and allow different types to work together based on shared abilities. This promotes a more modular and adaptable code base. So you have covered all the basic information required to start coding Swift and to understand Swift. So what next? Firstly, I would suggest you to keep practicing. The most important thing is to keep writing Swift code. Try to code daily, even if it's just for a short period. Experiment with the playgrounds to try out code snippets and build small focused programs. Consistent practice reinforces what you have learned and helps you build muscle memory for coding, making you more fluent in Swift programmer. Secondly, I would suggest you to dive into Apple's documentation. Apple provides comprehensive and up-to-date documentation on the Swift programming language on their developer website. This is the ultimate source of truth for everything Swift related. So make sure to explore it. Utilize online sources is the third thing that I would suggest. There are many excellent online resources available to help you learn. Swift explores website tutorials and online courses to supplement your learning. So do let me know what are the programming languages that you're trying to learn. Comment down below. Thank you so much for watching.
Staying ahead in your career requires continuous learning and upskilling. Whether you're a student aiming to learn today's top skills or a working professional looking to advance your career, we've got you covered. Explore our impressive catalog of certification programs in cutting-edge domains, including data science, cloud computing, cybersecurity, AI, machine learning, or digital marketing. Designed in collaboration with leading universities and top corporations, and delivered by industry experts, choose any of our programs and set yourself on the path to career success. Click the link in the description to know more.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.